problem analysis and solution technique. At this point in our study of thermodynamics, we have progressed sufficiently far that it is worthwhile to develop a somewhat formal technique or procedure for analyzing and solving thermodynamics problems. For the time being, it may not seem directly necessary to use such a rigorous procedure for many of our problems, but we should keep in mind that as we acquire more analytical tools, the problems that we are capable of dealing with will become much more complicated. Thus, it is appropriate that we begin to practice this technique now in anticipation of these future problems. Our problems analysis and solution techniques is contained within the framework of the following questions that must be answered in the process of a ordinary solution of a thermodynamics problems. The first question is, what is the control mass or control volume? Is it useful or necessary to choose more than one? To choose It may be helpful to draw a sketch of the system at this point, illustrating all heat and work flow and indicating force such as external pressure and gravitational process. Draw a sketch of the system at this point. The system at this point. Illustrating all heat and works. And indicating forces such as external pressure and gravitation. And gravitation. The second question, what do we know about the initial state? What do we know What do we know about the final state? For what do we know about the process that takes place? Is anything constant or zero? Is there some non-functional relation between two properties? Some functional relation between two properties. Is it helpful to draw a diagram of information is step step 2 to 4. For example, TV or PV diagrams. 6. What is our thermodynamics model for the behavior of the system? What is our thermodynamics model for the behavior of the substance? Such as, for example, steam tables, ideal gas, or so on. Seven, what is our analysis of the problem? That is, do we examine control surfaces for various work modes or use the first law of conservation of mass? For example, conservation of first law. Or the control mass. The 7, 8. What is our solution technique? In other words, from what we have done so far in step 1 to 7, how do we proceed To find what is desired, to find what is desired, is a trial and error solution necessary? And error solution it is not always necessary to write out all these steps, and in the majority of examples throughout this book we will not do so. However, when faced with a new and unfamiliar problem, the student should always at least think through this set of questions to develop the ability to solve more challenging problems. In solving the following examples available in the video parts section, there is some example related to analysis technique for a control mass. The next section is the thermodynamics property enthalpy.